Good evening, my YouTube viewers. Crystal here. What I wanted to do for you tonight was I wanted to give you the solution to Analytics Vidhya Agriculture Hackathon on the, what's today's date? Today's 19 September 2020. So the hackathon should be ending pretty soon, in the next day or two. I'm not going to win. I'm not even going to apply to do it, although I put my results in the solution checker, and I think my solution checker was like 82%, but the highest percentile was 95%, and since my highest percentage is 13 points less than the highest percentile, I'm not going to win. So there's not really a whole lot of point in me formally submitting my documentation to Analytics Vidhya, although I did use the solution checker, and the solution checker allowed me to keep track of my entries and keep progress, how my score was continuously going up. Now, I made my video this morning on random forest, and I said originally that it didn't work with SMOTE, but I looked on the internet and I found another code for SMOTE, and I decided that I'd try that and see if my percentage would increase with that code. And yes, it did increase. It went from an 80 to an 82%. And so I decided that I'd make a video to give you the solution for Analytics Vidhya Agriculture Hackathon. And the solution is random forest classifier with SMOTE. And the competition is ending within the next few days. This is September 19th, 2020. I don't know exactly when it's going to end, but it's going to end within the next few days. So what I'll do is I will give you the solution. I've got a GitHub account, so you can see my name on the GitHub account, so you can look me up if you want to follow along with me and use the code. I mean, obviously, it's not a winning code. You're not going to win this code, but it will definitely get you on the leaderboard. And I think that the way that I code is simplistic enough so that someone who doesn't know very much about programming can pick it up. Because I studied programming 30 years ago, and when I studied programming 30 years ago, it was done a lot differently than what it is now. Basically, what you had to do is you had to flowchart or pseudocode, and the programming was top-down, and you had functions. So you had a flowchart that went from the top to the bottom, and then you had functions and if statements and things like that. Well, in 30 years, programming has completely changed. For example, object-oriented programming was just becoming popular when I took my Pascal class, and I do remember at that time I actually was subscribing to a Pascal newsletter, and I don't think Pascal is even used anymore. I studied basic Pascal, COBOL, and C. And of all of those programs, I think people are using Visual Basic now in the Microsoft Office package, and they're using C++ or C# or something like that. But I'm not aware of Pascal being used anymore, and I'm not aware of COBOL being used anymore. And my sister started out as a COBOL programmer, and I don't think she's even using any COBOL anymore. She's using C now, and I think that she actually gives courses on Udemy in C, and I think she was trying to make them free. I don't know if she had any success in that or not, but that's just to give you a little bit of extra information. So the first thing we do with this solution to the Analytics Vidhaya Agriculture Hackathon is we import our library. So I tried to keep my library importation as small as possible. So I start out with the basics, pandas and NumPy, and then I work from there as to which libraries I'm going to need. I noticed that I put logistic regression in there because logistic regression was something that I was working on this morning, and I just never took it out. And basically, whenever I work on a program, especially if I'm working on a competition question, I'll write one program, but then I'll make a copy of it to use a different algorithm. So I started out with the logistic regression algorithm, and now I'm doing the random forest classifier. So after we imported the libraries, what I did was I wanted to set up my coding for the scalar. So we had standard scalar and min-max scalar. In the end, I decided to use the min-max scalar. I experimented with the standard scalar and the min-max scalar, and I had the best results with min-max scalar. So that's what I used, but I kept standard scalar in there anyway. And if you'll notice, because the solution to this program or to this competition question is you have to set up a multi-class system of 3 outputs, 0, 1, or 2. So for the min-max scalar, I decided that every column was going to be scaled down to a value from 0 to 2, because 0 to 2 is the response. And that was just the decision that I made. When I tried to do standard scalar, it just didn't work very well at all, but min-max scalar was fine. Then I loaded my data sets, and you can see that my data sets are also on GitHub. So if you want to use the data sets to experiment, the data sets are actually in my GitHub account. If you want to use them, you're more than welcome. So I checked the train account, and you can see all of the columns except the ID are numeric. In fact, they're all integers except one, which was a float. And I ended up, I think it was number weeks used right here, that was the float. And I ended up making that an integer because the algorithm wants to see integers. It doesn't want to see strings, and it doesn't want to see floats. Checked the test. The test is it's the same format as the train, except for the fact that it doesn't have the final column. The final column is your crop damage. Now, the final column is your answer, and since the test data frame is the data frame that we're going to be testing on, they're not going to give us the answer. So we wanted to see the sample sub. This is what Analytics Vidhaya wanted to see. They wanted to see a data frame with 2 columns, an ID column and the crop damage column. And the crop damage column is going to be either 0, 1, or 2. 0 means the crop is alive. 1 means other damage. And 2 means damage due to pesticides. So we checked out train info, and you can see that the ID was an object, but we're not going to be using the ID. And you can see that the number of weeks used was a float, and we ended up changing the float to an integer because that's what the algorithm wanted to see. The algorithm wanted to see integers. The same thing with the test. The test had exactly the same format, except it didn't have a crop damage column. We did a describe on the train, so you can see a describe of all the different numeric columns, and a describe on the test, and so you can see a description of all the different numeric columns as well. We wanted to see if there were any null characters in the train file and the number of weeks used. There were some null characters in the train file and the test file. So what I did was I set up coding to replace the missing values with the median. Because it was a numeric file, I wanted to replace all missing values with median. And that's the coding view. And then what we did after we replaced the zeros, the NAs, what we wanted to do was we wanted to check and see if there were any more NANs or any more zeros. And you can see that no, there's not any more zeros after we replaced those missing characters. So now you can see the train file. It's been cleaned up, shall we say. It's been cleaned up to be only numeric values. And the test file is the same thing. It's been cleaned up to say only numeric values, except for the ID column, which we're not going to be using for computation. What I did here was I gave you a heat map so you can see how the crop damage relates to the other variables, because your crop damage is your Y variable and everything else except for the ID encompasses the X variables. So now what we did was we did a group by. So we wanted to see how the damage related to all the different variables. And so we did a group by with all the different variables. Oops. And go back to that. Okay. Okay, so we just wanted to see how the group by related to all the different variables. And what I did was I did a little distribution plot, and you can see that there are three answers, 0, 1, and 2. And this is where we were going to have the biggest problem, because there were a lot of zeros, a few ones, and hardly any twos. And because there were hardly any twos, it was difficult to train the file. Okay, and that's why I experimented with logistic regression. And when I experimented with logistic regression and I didn't use SMOTE, it didn't pick up any of the twos. And I experimented with XGBoost and when I didn't use SMOTE, and it didn't pick up any of the twos either. The only algorithm that was able to pick up twos without SMOTE was random forest. So far, random forest seems to be the best algorithm to use as a solution. And then so I started doing the violin plots. We did a violin plot on the insects, and you see most of the insects were about 500. And you can see all the different estimated insects count, but the vast majority of them were close to 500, between 500 and 1,000, and it tended to decrease. And we did a plot on the crop frequency or the crop type, and you see that you had a crop type of 0 and a crop type of 1, and you can see that on the violin plot. And so we did a group by, and you can see that there were two different crop types. We did a violin chart of soil type, and there were two different soil types, 0 and 1. And we did a violin chart on pesticide use category, and you can see that there were three different pesticide use categories, 1, 2, and 3, with 2 being, well, really 3 having the most. We did a violin plot of number of doses per week, and you can see there's a lot. It seemed like 20 doses per week and 40 doses per week and 15 doses per week seemed to be the most common, but you can see that there were definitely 20 different numbers assigned with how many doses per week. and we did a violin plot on number of weeks used, and the highest number of weeks used seemed to be 30. And what we did was we converted this to an integer, because that's what the algorithm wants to see. The algorithm wants to see integers. It doesn't want to see strings, and it doesn't want to see floats. It just wants to see integers. And so we did a group by of the number of weeks used, and you can see that there were actually 64 different answers. Okay. So we did that twice, really. We did the number of weeks used twice, but it doesn't matter because it was done eventually. So just to make sure that the number of weeks used was in there. But for some reason, I did it twice, and it's not going to make that big of a difference. Although I didn't need to, only needed to do it once. And then I had a violin chart of the number of weeks quit, and the most of them was 0. But you see that we've got another long table of 51 categories of the number of weeks quit. We did a violin chart on the season, and there were 3 seasons. I don't know why they picked 3 seasons. I'm not a farmer, so I don't know if it's that they just don't do any farming on the winter. That's what I'm assuming. I'm assuming that they'll get crops in the spring, summer, and autumn, but in the winter they won't get any crops. Because I'm not a farmer, I can't say. I do know that I heard that in Maine, and this is way up north, that a lot of little ladies were growing their gardens in the winter. So I do think that it is possible, if you've got the inclination, it is possible to grow things in the winter, because that's just what I heard about people doing. But I guess if you're a farmer and you're in a big agricultural farm, you might not have the wherewithal to do any farming in the winter. But for some reason, they only allocated 3 seasons, with season number 2 being the most prolific. And so you can see here we've got the 3 seasons, and again it just verifies season number 2 is the most prolific. So the next thing we do is we set up our features. So our features are every column except for the ID column, which is a string. And all of these features are integers, because that is what the algorithm wants to see. And then the train labels is the Y value, and it's the crop damage column that has been reshaped to -1 and then 1. The next thing we do is we set up our X, Y, and X test values. So you can see X equals train features, Y equals train labels, and X test equals test features. The next thing that we do is we do our scaling, and I experimented with standard scaling and min-max scaling, and min-max scaling worked the best, so that's what I used. I set up min-max scaling on X, Y, and X test. The next thing we do now is we set up our SMOTE, and SMOTE is like it's synthetic sampling, because of these categories that don't have hardly any values in them, don't have hardly anything in them, then it's hard to train on them. And so what this algorithm does is it sets up a lot of synthetic information to enable the system to train on it. And the first SMOTE that I used, it just didn't make any difference whatsoever. But I found this formula right here from IMB Learn oversampling import SMOTE and Addison. And X resampled, Y resampled equals SMOTE fit resample X and Y. And so then after we set up our SMOTE, we use train test split to split our training data frame up into train X, val X, train Y, and val Y. And we use X resampled, Y resampled, random state equals 1, test state equals 15%. So what we wanted to do was we wanted to check the shape of train X, val X, train Y, and val Y, and you can see the shape. Train X and val X had 8 columns, but train Y and val Y have only 1 column. And now what we do is we set up our random forest. So random forest classifier with n estimators equals 10, and we fit that into train X and train Y. And then we predict on the test set. So RFC pred equals RFC dot predict val X, and we score it. We set up our scoring, which is accuracy score, F1 score, and recall score. And these are 86, 86, and 86 respectively. The next thing we do is we set up our params equals RFC.getParams, and then we print that. So that just tells you what the parameters are. And I suppose that if you want to change the parameters, now's your opportunity to change them. And then we set up a confusion matrix. So your confusion matrix is val Y and RFC pred. So there's your confusion matrix if you know how to read it. And the next thing we do is we transform our confusion matrix into an array. The matrix is stored in a variable called conf matrix. So conf matrix equals NP array, confusion matrix, val Y, RFC pred. And then we create a data frame from conf matrix array. The rows are for test and the columns are for preds. So basically so now we've got alive, other causes, and pesticides. And so you can see that in this instance, using SMOTE, we've got this many 2 values. Without SMOTE, it's a very small number. It's about 145 or 146, something like that. I don't remember exactly, but it's a very small number. But the SMOTE gives you like synthetic data to test on, so the algorithm or the computer can train on it to further be able to analyze whether a value is 1 or 2, and 2 in particular, because 2 is the minority. And then we set up an accuracy score. The accuracy score is 86%, and we print off a classification report if you want to read that. The next thing we do is we predict on val X, and we have to flatten val Y and Y pred. And so we flatten val Y and Y pred. We put that into a data frame, and so you can see the predicted values and the actual values. So you can see over here we predicted a 2, but it was actually a 1. And that's it. Then what we do is we fit RFC into our X and Y. I suppose we could have done it into X resampled and Y. No, we couldn't do it in X resampled and Y resampled, because the resampled was just to give you synthetic data, but you don't want the synthetic data in your test file, so you have to fit it on X and Y. And then so you see that you've got your random forest classifier, and you've got it's telling you what all of the hyperparameters are. And so predictions equals RFC predict X test, and X test is what we had given the name to and called test features. And now you see predictions, which gives you an array. And now we take our submission and we convert it to a data frame. And this is the submission that I submitted to Analytics Vidhya, the Agriculture Hackathon. And I got about an 82 percentile, which is about a 2% increase from Random Forest Classifier without the SMOTE, which is why I wanted to make this video to show it to you. And you can more than welcome to use my code. It's on GitHub, and more than welcome to look me up and follow along if you want to use the code, because I said it'll get you on the leaderboard. You're not going to win with this code, but it will get you on the leaderboard, and it will give you a little bit more understanding of data science and the process that we take to solve problems in data science. So if you like my video, please like, subscribe, and share, and let me know any comments that you may have in the comment section down below. If you like the work I do and you want to make a donation, I have my email address in the comment section down below. And the reason why is because I don't have enough subscribers to monetize, so I have to ask for donations because of that. And thank you so much for watching this video, and I look forward to making another one for you.